Welcome to the High Framework Learning Channel. My name is Antonio, and for almost 20 years, I worked nonstop as a data scientist and governance specialist. And now I'm here with you, my friend. Let's stop thinking that artificial intelligence can replace human intelligence. Artificial intelligence, it's not a mystical black box, and it's not human thinking. At the very core, this whole revolution from AI comes down to pure mathematics and mechanical scale. If you want to master this new era of computing, you have to understand the core engine. We are going to strip away the corporate type and look directly at the actual logic driving the technology. Think of AI like a Russian doll with distinct layers of capabilities. The outer layer is AI, which simply means building intelligent machines. Inside that is machine learning, where machine processes they recognize general patterns from data. Deep learning then also goes very further than that by using massive networks to process unstructured data like video or audio. At the absolute center sits large language models, which can focus only on understanding the human language. At the level one, machine learning is fundamentally just drawing a boundary line to separate data points. Look at how a system classifies music. It takes key parameters like tempo and energy, plots them, and draws a clean mathematical line between genders. Now, the machine do not hear the music or feel the music pace. It simply calculates the exact distance from the boundary line to make a statistical decision. When you move to level 2, the simple boundary line collides with massive architectures that can scale up. And to manage thousands of dimensions at a simultaneous way, deep learning relies on an incredible dense web of connections. Consider the sheer volume here. The human brain operates with roughly 100 billion neurological pathways. The underlying large language models that we use today handle hundreds of billions of distinct parameters to process information. At the level 3, we must accept that a cold reality about language modeling is actually very clear. It's not human reasoning. It is a 50,000 word sorting game. The engine functions as a massive probability funnel. When we give the model a sentence, it does not understand the meaning, simply reviews the library that uses as a source to predict the single most statistical relevant next word based on pure classification and predefined tokens as well. Now, how is this engine actually built? Let's go in terms of the architecture of a large language model. Like the first one that was very much known to the public out there, that was the ChatGPT. This GPT model relies on three core pillars: generative, the G, pre-train, the P, and transformer, the T. It generates tests by constantly predicting the next word sequence at an extreme scale. First, feds massive volumes of internet text, data, but also books to build the internal model. Second, uses the transformer architecture that can apply attention to focus only on your prompt. And a role model is a chaotic scholar that completes patterns without any kind of direction. To make it useful, companies run it through a strict three-stage refinement pipeline. First, the pre-training on the internet data. Next, instruction fine-tuning, where high-quality examples teach the model to act as a direct assistant. And finally, the human feedback aligns the system to remain safe and polite. Now, why do these advanced engines suddenly go off the rails and hallucinate? Happens because the system it's mainly driven entirely by statistical probability, not absolute truth. And by default, the model has zero active connections to a verified real-time database. When you combine a next word statistical engine with the confident tone of internet data, you get a highly confident hallucination. But we solve this fundamental issue through a process called grounding. And instead of letting the engine guess, we bypass statistical uncertainty by giving the model a temporary working memory and deterministic guidance, and specific requirements. We then inject verified documents directly into the context window. And this forces the large language model engine to extract the final response just from your provided sources, your provided data, guaranteeing the accurate answer. And when you scale the next word prediction to trillions of parameters, something fascinating really happens. The system develops emergent abilities that was never explicitly trained to perform. This is the emergency of scale. And suddenly these models, they achieve academic excellence, like passing the uniform bar exam in the top 10%, or executing complex out-of-the-box translation, mainly achieving those tasks in a very or without effort. Let's say it like that. And to steer the engine effectively, you must master the prompting playbook. For example, the zero shot prompting asks the model directly, relying entirely on the pre trained internal weights for general tasks. Then, few shot prompting, for example, provides formatted examples, which in a temporary way trains pattern recognition within the context window. And finally, the chain of thought forces the middle reasoning, which is very much essential for breaking down complex logics and multi stage business problems as well. Now, why does chain of thought work so well? Because standard prompts they force the model to make a massive, mistake-prone statistical leap across a complex problem chasm, resulting in high failure rates. By adding a simple phrase, you force the engine to build a sequential working memory on the screen and tackles sub-problems one by one, verifying the logic and hitting the target goals with high accuracy and determinist levels. And as the saying goes, English is the hottest new programming language, among very other languages as well. And you are sitting in the driver's seat. This system possesses no human intelligence, no awareness, and no real emotions. It is really pure, massive scale statistical probability. But if you control the language that we, the humans, control, for example, the English, German, French, and so on, you are able, without having the programming skills, to interact with the machines and ask the machines to do something specific, very much mimicking what the humans are also able to do in very specific tasks. Now, that you have a better understanding how the mechanical engine works, you can steer it with precision. But remember, it isn't magic, it is mathematics.